Hi guys, welcome to DHARANI'S Max channel. Before going into this video, please like and subscribe for more videos. So in this video, we are going to cover exercise 1.3 ninth sum. So we have learned till exercise 1.2 and some sums in exercise 1.3 also. So in this video, as I said, we are going to cover ninth sum. So let's see the question. Here we go. Question 9. Classify the following as rational or irrational. So what is a rational or irrational? So numbers are in various forms that can be said as natural number, integers, whole numbers, rational or irrational. So what should we classify here? They will give a particular set of number and we have to say whether it is rational or irrational. So what is rational? Rational number are in the form p by q, where p and q are integers and q is not equal to 0. The definition of rational and irrational we have also seen in the previous video, even though let's recap now. So rational number examples, we can say it as 1 by 10, 2 by 3, and rational numbers can also be said as fractional, fractions, as they are in the form fractions also. So let's see irrational numbers now. Irrational numbers are the set of numbers that is in the form decimal. So you know what are decimals? A particular number containing a point, for example 2.3, 4.1. Here 1.3 is having a point here, so it is an irrational number. So we have to classify whether it is rational or irrational. So let's see the first subdivision for ninth question. Here we go. First question, root 23. We can write 23 as square of some number. Okay, so anything in the form root or some root numbers are either rational or irrational. That is, we can say root 4 is rational. Why is it so? Because root 4 gives the value of 2. 2 is a whole number or a natural number. Okay, so it comes under rational form, as rational contain integers, whole numbers and natural numbers in the denominator as well as the numerator. You can say only 2 is there, where is the denominator? As I have said, every number has defaultly denominator as 1. So here it is root 23. So it is not a perfect square. That is, they have said here. So root 23 is not a perfect square. What is perfect square? As I have said, root 4 is equal to 2. 2 into 2, we can get 4. That is what root 4 is equal to 2. Root 64, we can take root 64 is equal to 8 into 8. Any number that is doubled is equal to the value plus root. Okay, for example 9 into 9 is doubled here, 9 is doubled here, and we will get the value as 81 or root 81. So here root 23, it is not a perfect square. We can divide root 4 or root 9 or root 16 or root 25, but not root 23, because its value is in the form decimal, that is 4.796. So hence it is irrational number. Okay, see here second one, classify the following numbers as rational or irrational. Okay, second subdivision, root 225. Here root 225 is a perfect square. As I have said, here it is not a perfect square. So let's see what is perfect square here. So root 25, that is 15 into 15, we can get 225. So when the 15, when here we can get 15, right? 15 square is equal to 225. That is 225. When the square goes that side, it will take it as root. Okay. So when 15 square is here, When this square, this 2 goes that side, it will become as root. So 15 is equal to root 225. So we can say the value as 15. So 15 by 1, since it is in the form p by q. As I have said, any number has denominator as default 1. So it is a rational number. Okay. Here the third subdivision, 0.3796. Here it is a terminal decimal expansion. You know what is terminal decimal expansion? Terminal decimal expansion are those when we divide two particular number, it will give in the form decimal form as well as it will end. For example, 0.2356. Okay, so what is non-terminating? Actually, terminating and non-terminating are not same. Non-terminating is that if here take the same number, we can assume it as 0.3796 dots dot dot dot. So when we are representing it with dots, it is said to be non-terminating decimal expansion, as the particular decimal expansion is not ending. When it is not ending, we will represent it as dots. So here we cannot see any dots and even a bar. So what does that bar include? So what does that bar say? The bar says that the bar on the particular number is going to be repeating. So here we cannot see any bar or dot, so it is a terminating decimal expansion. When it is a terminating decimal expansion, we can convert it into rational number. Okay, in the before videos we have seen how to convert a terminating decimal expansion to rational number. So when it is going to be converted into rational number, it comes under the category rational number. So third subdivision answer is it is a rational number. So let's see the next. Fourth subdivision, 7.478 dots. So here you can see the dot. So what it says? It says that it's not going to be end. It is going to be repeating. So the particular numbers, that is 478 dots, it's going to be repeating. And we can also say it as 7.478. As you can see, 478 is again repeated as 478. So we are going to represent it with a bar. So when there is bar as well as the division is not ending, it is said to be as non-terminating, and here it is represented with bar. It is said as repeating decimal expansion. So therefore it is a rational number. Even non-terminating numbers can also be converted into rational numbers. So fourth subdivision answer is rational numbers. Classify the following numbers as rational or irrational. So whether here fifth sum, that is fifth subdivision, 1.101001, then 0001, then 401, then dots. So here dots represent that it's not going to be ending, and it is said as non-terminating, and here the numbers are not repeating. The numbers, even though 1010 is repeating, but it should repeat in the particular pattern. Here the pattern varies, right? Here 10, here 20, here triple zeros, here 4 zeros. So that the pattern should be same, then only it is said as repeating number. So it is non-repeating decimal expansion. Therefore, it is a irrational number. If you try to convert this into a rational number, you will not get the answer. You cannot convert it into a rational number at all. So here you can make it as a rational number, here also. Okay, so third subdivision answer rational, fourth subdivision rational, and fifth subdivision irrational number. Thanks for watching. Subscribe, guys. Like, comment, share. See you in the next video.